start of Unit 5. Our opening lesson is a review lesson. You did this as a 6th grader and possibly as a 5th grader. We're going to be solving one-step equations today. Remember, equations are where you have an equal sign present. You're saying an expression or a value is the same as another value. Look at the example in front of you. Something plus 2 equals 7. Now you might go, Mrs. Kluver, I know what that is in my head. It's 5. And while yes, some of the equations that we're going to work with today, you may be able to just do the math in your head, but we need to show on paper the math that's going on in our head. Back as a 6th grader, if you were here at RMS, we talked about, hey, in this unit, we need to show our work. So again, you need to show your work, even if you're able to do it in your head, because our main goal is to be able to show equality, to use inverse operations. So I'm going to just review what you already saw. I can use properties of equality, undoing inverse operations, to solve one-step equation with positive integers. So all of our answers today should be positive integers. Okay? That means positive whole numbers. What's the purpose or the goal of solving equations? It's to get the variable by itself, to find the value of the variable. At this point in our lesson video, if you do not have your Unit 5 note packet yet, you need to find a sheet of paper. And on that sheet of paper, I'd like you to copy my note sheet in front of you. So pause the video and get a sheet of paper organized. The first chunk in your notes that you created on the left-hand side, you have the question, what are inverse operations? Inverse operations are operations that undo each other, and we need them when solving equations. So the inverse, the opposite of add, would be what? Subtract. What about the opposite or the inverse of subtract? Add. The inverse of multiply. What will undo multiplication? Division. And how about the inverse, the opposite of divide? What will undo division? Multiplication. We're going to use inverse operations to solve one-step equations. Make sure you have the first part of your notes filled in with the inverse operations. Pause the video and write down example 1 and 2 in your notes. On the left-hand side, our question is, how do I solve one-step equations? These two equations in front of you are addition equations. So what are we going to have to use to solve them? Well, what will undo addition? What's the inverse of adding? You got it. Subtracting. So we need to use adding's inverse, which is subtraction. Also, we want to remember to maintain equality. Something that I like to do is draw an arrow from my equal sign down. It reminds me to maintain equality and it helps me keep my work organized. Equation 1, 49 plus x equals 310. With this equation, we don't know what part of the expression is. We know what it needs to equal. That's why we need to use inverse operations. We need to get x by itself. Therefore, we need to get 49 out of there, yet maintain equality. This right here is a positive 49. Positive is the same as plus, right? So what will get the positive 49 out of there? If we subtract 49. So let's go ahead and let's subtract 49 from both sides, maintaining equality. 49 minus 49, well, that gives me 0, and that means it's out of there. Therefore, I have x all by itself, so I'm going to put a slash through it. Here is a great moment for me to pause and say, if you don't have a calculator in front of you, go get one. 310 minus 49, that's going to give us 261. Now, before we go, woohoo, we're done, we want to make sure that we solve correctly. So we're going to use substitution. We're going to take our value for x and we're going to plug it into our expression to see when we solve if we actually get 310. So let's go ahead and let's do that. We have 49 plus 261. Does that equal 310? Yes, it does. We solve correctly. Let's go to example 2. Something I haven't mentioned yet is these are one-step equations because look at, they have one operation in them. This term is being added to this term. There's only one operation. That's why we call it a one-step equation. Pause the video and solve this one-step equation for y. Come back and check your answer with mine. When you solve for y, did you get y equals 43? That's what I got right here. This is a plus 14. So we need to use the inverse operation. We need to undo the addition, and that means minus 14 from both sides, leaving us with 43. Let's check to make sure our answer is correct. So we're going to go ahead and we're going to plug 43 in for y. So we'll take 57 equals 43 plus 14. Well, 43 plus 10 would be 53, plus 4 more would be 57. We solved correctly. If you didn't get y equals 43, pause the video and look at my work. Otherwise, let's go on to the next two examples. Example 3 and example 4, write them in your notes, pause the video while you do that. These two equations in front of you are where you're taking a term and you're subtracting another term. So how do we solve one-step equations? Well, these are subtraction equations. So what do we need to use to solve subtractions equations? What will undo subtraction? Addition. It's the inverse operation. So let's go ahead and let's do number 3 together. X minus 12 equals 34. I'm going to draw my arrow down, helps me keep my work organized, and remember to maintain equality. We have x minus 12. Remember, when we're solving equations, we want to find the value of the variable, get it by itself. So I need to get this minus 12 out of here. That means I need to add 12 to both sides. So let's do that. We're going to add 12. We're going to add 12. This is a negative 12 plus 12. That's going to give me 0. So it is gone. I'm left with x on my left side equals 34 plus 12. What is that? 46. Now before I move on, I want to make sure I did this correctly. So I'm going to take 46 and plug it in for x in my equation. Do that with me in your notes. So we have 46, that's going in for x, minus 12. Does that equal 34? Well, 46 minus 10 would be 36. Sorry, minus 2 more would be 34. We got it. You probably can infer what Ms. Kluver is going to have you do. With problem 4, go ahead and pause the video. You solve this equation for the value of y. Come back and check your answer with mine. When I solved this problem, I got y to equal 47. Now you can see, very similar to problem 2 or example 2, here I had the number first and then my variable. I just switched it so it was my variable coming first and then my number. That is just how I like to see it. So there is my final answer, but before I move on, so I shouldn't say my final answer, I want to check to make sure that I didn't make a mistake, because that's something that can easily happen. So let's plug 47 in for y. So we have 16 equals 47 minus 31. If I'm at 31, how much to get to 47? Let's see, well, 31 to get to 40 would be 9, and then I need 7 more, so that'd be 16. Absolutely, 47 minus 31 is 16. We solved this problem correctly. Let's look at example 5 and 6. Can you infer right now what type of equations they're going to be? Pause the video and write down example 5 and 6 in your notes. How do I solve one-step equations? This time, our equations are taking terms and multiplying them together. So what will undo the multiplication? What is the inverse operation of multiplying? You got it, dividing. But remember, when we're working on our algebra skills, multiplication is going to show up as invisible multiplication, and division, we need to make sure we use that fraction bar, okay? So our equation here, I just want to make sure to maintain equality. So I'm going to bring down my arrow, reminding me to carry my equal sign down every step I take. It's a one-step equation because it's 4 times x. That's the only thing that's happening in my expression. One operation is one step. So 4x equals 216. I need to get x by itself. That means I know I need to use division because it's a multiplication equation. But what am I dividing both sides by? Well, if my goal is to get x by itself and find the value of x, I need to divide by what is attached to my variable. Therefore, I need to divide by 4. So I'm going to divide by 4 on both sides. 4x divided by 4, that gives me 1x. And we don't have to write 1x as a 1 and then an x. We can write it as just x is the same as 216 divided by 4. Well, 200 divided by 4 is 50. 16 divided by 4 is 4. What's 50 plus 4? 54. Now, before I go, woohoo, I'm done, I'm going to use substitution. I'm going to take 54 and plug it in for x. So 4 times 54. Substitution, remember we got invisible multiplication, so it doesn't become 454. It's 4 times 54. Does that equal 216? Is this equation true? Yes, it is. Again, you can check these on your calculator. Pause the video and you solve for the variable y in example 6. Come back and check your answer with mine. When I solved this one-step multiplication equation, I used division. I divided by 5 because 5 was attached to my variable. When I divided 95 by 5, I know it was going to be divisible by 5 because 95 ends with a 5. I got 19. Let's check to make sure we solved that correctly. Practicing our substitution skills, we're going to take 19 and plug it in for y. So 95, does that equal 5 times 19? Well, 5 times 10, I'm going to use distributive property, is 50. 5 times 9 is 45. What's 50 plus 45? 95. We solved this correctly. All right, 7th graders, we have 2 more examples, so let's get ready to write those down in our notes. Here they are, example 7 and example 8. Pause the video and write those in your notes. Looking at these, remember, we use a fraction bar to represent division. So these are one-step division equations. What will undo the division? Multiplication. They are inverse operations of one another. Let's go ahead and let's do example 7. X divided by 8 is the same as 13. So I need to remember to maintain equality. And again, it just helps me keep my work neat, that arrow coming down. Division, what will undo that? Multiplication. So I need to multiply both sides by what value? Well, what's connected with the variable? 8. So I am going to be multiplying both sides by 8. Now you might go, Ms. Kluber, how you're setting this up, you're working out instead of working down like you have been. I'd like to explain really quickly about how this part right here works. This part of my expression, when I multiply x divided by 8 here, this actually gives me 1x. 1x! That means this is out of there. I'm left with just x. But how does that work? You do not need to put this in your notes. Just listen for a moment. So I have, right now I'm showing you 8 times x divided by 8, right? And I'm saying that that gives you 1x. How is that possible, Ms. Kluber? Well, how do you write a whole number as a fraction? You put it over 1. It's multiplication. You know how to multiply fractions. Simplify before you multiply. Take every numerator to every denominator. 8 and 1, I already have a denominator of 1, or I have 1 in the problem, I'm done. 8 and 8, I can simplify there. I can divide both of those by 8 to give me 1 and 1. X over 1, I don't know what x is, so that's as simplified as I can get there before I multiply. Let's take our numerators. 1 times x, well, that's going to give me 1x, which I can write as x. And 1 times 1, well, that's going to give me 1. Well, look at that. There's my invisible 1. Do I need that there? Absolutely not. So do you see how in division equations, when we're multiplying, that it gives us just the variable? I know, it can be a little tricky. I'm going to go ahead and I'm going to erase this because you didn't need to have that in your notes. But now you understand, or at least you see that it's not just some crazy thing, how multiplying by 8 here in my expression, well, that's going to give me 1x, which I can write as just x. 13 times 8. What is 13 times 8? It'd be 80 plus 24. That's going to give me 104. Now, I want to check to make sure I did my work correctly. So I'm going to take 104 and plug it in for x. 104 divided by 8, does that give me 13? Yes, it does. Pause the video, you do number 8, come back and check your answer with mine. When I solved for y, I got it to equal 102. I needed to get the 6 out of here. Y was being divided by the 6, so I used multiplication. I times by 6. Notice how I'm writing that multiplication, 7th graders? That's intentional. We want it to be diagonal. Times by 6 on both sides to maintain equality, and that gives me 102. If we check to see if we solved it correctly, let's plug 102 in for y. So we would have 17 equals 102 divided by 6. Is that true? Yes, it is. Now, if your answer did not agree with mine here in number 8, pause the video, look at my work, write any questions down in your notes, and ask them when we come back together. If we were to sum up what we just spent a handful of minutes doing, it would be that we used inverse operations to undo the operation in an equation. So that's how we got to start with solving one-step equations, is recognizing the inverse operations when it comes to our 4 basic operations that we have used so much.